Hey there everyone, today we'll be learning a new chapter known as the Binomial Theorem. So then, what does the word binomial mean? Binomial basically means two. What do I mean by that? Whenever you're expanding two terms, it will be known as a binomial. So then, what can be an example of a binomial term? Basically, whenever we expand a plus b whole square, it is a binomial, and you already know that this becomes a square plus 2ab plus b square. What can be another example of this? Whenever we are expanding a plus b cube, right? Whenever we expand a plus b whole cube, we say that this becomes a cube plus 3a squared b plus 3ab squared plus b cube, right? This is how we expand a cubic term. But now then, what happens whenever I am expanding a term which has a power greater than 3, for example, a power of 4, or for example, a power of 5, or to the extreme, a power of 40? How am I supposed to expand these type of terms? I can't just, what I can do is a plus b into a plus b into a plus b into a plus c. But as you can see, this is a very tedious task. It will take a lot of time. So then, what is a method of expanding a term whose power is greater than 3 without a formula? Now then, let us see how we can apply the binomial theorem. We can say a plus b power n can be any number. N can be 40, n can be 5, n can be 4. It can be any number. Now then, how am I supposed to expand this? What I can, the first thing I am supposed to do is write nc0, right? As the first term, as the first thing, I will write nc0, and then I will write the first term that has been given to me, which is a. I will say a power n, and then I will write b as 0. Now then, we move on to the second. What we will now write is nc1. See, this 0 now is added 1, right? We add 1 to this 0, it becomes 1, right? 0 plus 1 is 1, and n remains the same, so we say nc1. And then this a power, now u minus 1 from this n, so we say n minus 1. And this b, 1 is added to this b, so b becomes 1. Basically, what is happening right now is that this 0 is the same as the 0 over b, and this one is the same as the 1 over b. So basically what is happening is that we say this as r. The power of b is r always, right? So here r is 0, so the power of b is r, which is 0. Here r is 1, so the power of b is also 1, because the power of b is always r. What we can generalize this as nc0 a n minus r into b r. See, this is how we are generalizing this. This is why we did n minus 1. Basically, we are doing right now here is n minus r, and here we did n minus r, which is n minus 0. So I can just write this as n. Now then, we move on to the next term. We say nc2. See, once again, we added 1 to the previous one, so this becomes 2, and a becomes n minus 2. This r, n minus 2, right? This is n minus r. Here r is 2, and then here r is 2 as well, so I'm doing n minus r as I told you here. Now we do b. B has a power of r, which is right now 2, so this becomes r. Now then, we move on to the next one. We say nc3. Once again, we add 1 to the r, so this becomes nc3, and then a becomes n minus 3, n minus r, so n minus 3, r is 3. B has a power r, r here is 3, so b becomes 3, and this keeps going on until we reach n. See, as you keep plussing 1 in this, it will reach the term n, and then a becomes n minus n, which is 0. So I can just write this as a power 0. And now b has a power of r here is n, so b becomes n. So this is the binomial theorem. Now then, let me do a question for you so that you may understand it better. All right, how about the simplest question? Let me say that x plus 1 squared. How about this? See, normally you can just solve this with x square plus 2 into x, b is 1 plus 1 squared, right? So this comes out as x square plus 2x plus 1, right? Now then, how about I solve this using the binomial theorem? So then this comes out as, remember that here x is a and 1 is b, all right? As I did here, the first term is a, the second term is b, the second term here is 1, which is b. So then let's solve this. Let's say that a, remember as I did above, nc0, nc0. What is n here? N is 2. So rather than writing n, I can say 2c0. And now it says a powered n. What is a? X. What is n? 2. So I can say 2. And then b. Here it says b power 0. So what is b? 1. Its power is what? 0. Now then, let's add. Now it says 2c1, right? Here n is 2 and c is 1, right? Remember that r always gets added by 1 each time you write a new term. Now here a is once again x, and we can say 2 minus 1, as above we said n minus 1. N is 2 and r is 1, so 2 minus 1. And then b is 1, so I can say that b is powered 1. B is 1, power is also 1. And now it is 2c2, right? The more further you go on, the power of r increases. Once again, n is 2 and this is 2, so 2c2. A is x, and here you do n minus 2. N is what? 2 minus 2. And b is squared. B is 1 squared. Now we don't go any further. As I said, that whenever we reach this part, we end our solution. See, we have reached this part. See, NCN. 2 is n, 2 is n. See, similar thing happening here. So we will stop here. Now then, let us resolve this a bit more. We'll say 2c0. Now then, how am I supposed to resolve this, right? What is this c? Basically, right now on the screen you can see that there is a calculator, and on that you can see above the divide sign that there is NCR. Now then, how am I supposed to access this NCR? What you do is you press the number before C, which is right now 2, and then what you do is press shift and then you press the divide sign which has the NCR on it. So now we have C, and now all I need to do is press the second number which is after C, which is 0, 2C0. The calculator gives us the answer 1. So this is the result of 2C0, 1. And x remains x square. And 1 power 0 is 1. Plus 2C1. Once again, calculator, we put in 2. We press the shift button. We press C. We press 1. This comes out as 2. And x, 2 minus 1 is x powered 1. And now 1 power 1 is 1 plus 2c2. Once again, calculator, we press 2, we press shift, we press C, we press 2. This comes out as 1. X, 2 minus 2 becomes x power 0. And this 1 power square is 1. Now then, let us resolve this. This becomes x square plus 2x plus 1, right? X power 0 will become 1. Anything that has a power of 0 always becomes 1. As you can see that even after applying the binomial theorem, we got the same answer. See, this is how we are supposed to apply the binomial theorem. Alright, now then there are a few things that we need to keep in mind always. First of all, there are tidbits which will help you in your exam if you just remember them, because we do this in every question. What you need to realize is that this is the first term, this is the second term, and this is the third term. Alright, you should remember that if anything has a power of square, you get 3 terms out of it. If anything has a power of 3, you get 4 terms out of it. Alright, this is how we are supposed to remember the terms. So this is the first term, this is the second term, and once again this is the third term. So then, what is so special about all this? Well, basically in the first term, as we just saw that 2c0 gave us 1, right? So is there any point of writing 2c0? We don't need to write, because anything you multiplied by 1 will not affect the actual term, so here I did not need to write 1, and same goes for this. See, 1 has a power of 0. I don't need to write the term which has a power of 0. It is basically useless. So what I could have done instead was just write x square plus 2c1 and just moved on, right? This is one thing that you can do in your exam. Why am I saying to remove 2c0? Here, in your calculator, to any term with c0, it will always give you 1. So 4c0 will give you 1. 10c0 will give you 1. Anything that you do with c0 will always give you 1. That is why we just ignore this whenever we are doing our questions. As we'll do more questions, I'll even show you what I mean. Now then, another thing. There are few points that you must remember, that anything which is which has c0 will always give you 1, right? So you don't need to plug it into your calculator. Always know that any number with c0 will always give you 1, and any number which is like this ncn will always give you 1 as well. All right, so if I do 2c2, it will give you 1. If I do 4c4, it will give me 1. If I do 10c10, it will give me 1. All right, so make sure you know that any thing like this will always give you 1. So once again, you don't need to plug it into your calculator. You can just solve it using your own mind. Now then, there is another thing that you need to remember, that anything which is with c1 will always give you the n. What I mean by this is, if I do 4c1, it will give me 4. If I do 2c1, it will give me 2. If I do 10c1, it will give me 10. So what we can see by here is that anything with c1 will always give me the number that I applied with the c. Basically, it will give me n back. So once again, you do not need to plug it into your calculator. Just remember that this gives you that. All right. Now then, there is one last thing. What is this c, right? You might have been wondering, what is this c and why am I using a calculator to resolve this? What is the actual thing about it? Basically, what you first need to learn is what a factorial is. What a factorial is. Factorial is basically, it is much easier if I write it. So if I say 3 factorial, what this does is basically minuses 1 each time. So if I say 3, it is multiplied by 3 minus 1, and now it is multiplied by 3 minus 2. All right, and now it ends here. All right, so it becomes 3 into 2 into 1. Basically, it ends when you reach 1. So this gives you 6. And if I say 4 factorial, it will go 4 into 3 into 2 into, basically it counts down back, and then it multiplies all the backward counting that we have done. So 4 3s is 12, 12 2s is 24. So this gives a factorial of 24. If you are unsure, like what happens when you get a big number, right? For example, you get 10 factorial. Now you are not going to be so harsh on yourself and like do 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. It is a very tedious task, right? So then how are we supposed to make this tedious task easier? What we can do is use our calculator. We can say 10 We just write 10 on our calculator, and then above x power minus 1 is the factorial symbol. So how do we access that factorial symbol? We basically do shift and then press the x powered minus 1. This gives us 10 factorial, and now when I press equals to, it gives me the answer directly, which is 3628800. So once again, we can use the calculator to find the factorial answers as well. Okay, so then why did I tell you about this factorial? See, what we need to learn is how to expand this C. What we do is basically expand until R. So it would be better if I just showed you a simple question. Let's say we have been given 4C 2. We will expand this factorial only 2 times. So what I can say is 4 into 4 minus 1. See, 2 times. 1 time, 2 time, and below 2 factorial. Always remember that R is 2. So what I meant here was NCR is equals to n into n minus 1 into n minus 2. This keeps going on until r times. Basically, it keeps going to r times. So what happens here is 4 into 3 over 2 into 1. So this becomes 2 ones are 2 twos are. So the answer is 6. Let's do another one. Let's say we have been given 5C3. Now then we will count down 3 times. So 5 into 5 minus 1 into 5 minus 2. See, 3 times. 1, 2, 3 over 3 factorial. 3 factorial is 3 factorial. And now let us resolve this. This becomes 5 into 4 into 3. And this becomes 3 into 2 into 1. So this becomes 3, 3. 2 ones are 2 twos are. This becomes 10. See, that is how we resolve C in binomial. Now then, let's do the simple one, 5C1. So what I'm here only going to do is write 5 over 1. We won't go down more because, as I said, we go the amount of times that this R is. So this becomes 5. Same for 4C1. 4 over 1 factorial, which is 4. Now then, let us do a question regarding the binomial theorem. So then, what is it asking? It is telling us to find the first 4 terms in the expansion of 1 minus x powered 6. So, the first 4 terms, remember how we count the terms. This is the first term, second, third, and then the fourth. So then let us expand this. It is saying 1 minus x power 6. So then, as always, I told you that we don't need to write NC0, which is here 2C0 and that this. So I will not be writing 6C0. I will just write A. Remember that this is A, this is B. Don't forget the binomial theorem. Now then, what I can do is say n1 power 6. I don't need to write b power 0, which is minus 6 power 0, because it will once again turn out as 1. And then 6c1. Once again, this is how it goes as the r is added by 1. And then a as 1, 6 minus 1. Remember n minus r, 6 minus 1. And then this b is minus x. Don't forget that this b is minus x, not plus x, minus x. We will use this minus here. So this becomes powered 1. Now note that now we already have 2 terms. So we need 2 more. See, first term, second term. So we say 6c2 into 1, 6 minus 2 into minus x squared, right? R increased by 1, and this was n minus r, which is 6 minus 2, and this is b minus x squared. Now know that we have 3 terms by now, so we only need 1 more term. 6c3 into 1, 6 minus 3 into minus x cube, right? Know that b has a power of r, so and this is n minus r. Now that what we need to do is resolve this. 1 plus 61 will be 6 into 1, 6 minus 1 powered 5 into minus x, plus what is 62? This time use your calculator. It will give you 15 into 1, 6 minus 2 is 4, and minus x will give me x squared. Know that any negative number that is squared will always give you a positive one. Plus 6c3. 63 gives us 20, and 1 6 minus 3 gives us 3, and minus x cube. Know that an odd power does not change the sign. So this becomes 1 minus 6x plus 15x square minus 20x cube. And this is how we solved the first four terms of this expansion. Now then, it is telling us use this expression, otherwise find the first four terms in the expansion of this. Now it is asking us to find the first four terms in this expansion. Now then, let us do that. 1 minus x square over 2 power 6. So then, first of all, what we need to do is notice a similarity. If we notice, this is same here, a is same here as well. Only thing that has changed is the b, right? It has changed from x to x square over 2. So then, we do not need to do the whole expansion again. All we can do is replace this x. All we need to do is replace this x. So what I can do is 1 minus 6 into x square over 2, and then I can do 15 into x square over 2 squared, and then minus 20 into x square over 2 cube. This becomes 1 minus, know that 2, this turns out as 2 ones are 3s are. So this becomes 3x square plus 15 x power 4 over 4, right? Because it had square, so this will become x4, and 2 squared becomes 4, and this is minus 20 into x. 2 into 3 becomes 6 over 2 power 8. 2 power 3 becomes 8. So then this becomes 1 minus 3x squared plus 15 over 4 x4 minus 20 over 8 is 5 over 2. So this becomes minus 5 over 2 x6. So this is the expansion of binomial. We will do the rest of the questions in the next lecture.